Having covered the basics of intellectual property, I thought I'd finish with there'll be some overlap here, but I want to speak to the IP strategy again, and specifically the IP strategy for fundamental innovations. In the previous lectures, we've been talking about the generic uses of intellectual property, what's in them and how to claim them and the different parts of them and some strategic issues, how to use them. But, you know, we now need to intersect this in implementation with the fact that recall that some fundamental innovations take at a minimum 10 or 15 years to get to the marketplace, and that many of them take longer. And considering that patents only last 20 years, doesn't this cause a problem? Well, the good news is that if it's 10 or 15 years to, the from aha moment in the lab to first commercial dollars, it tells you that there's no rush in the sense that, you're going to be lucky to have 10 years left on that patent when people really start to use it. Now, of course, as we mentioned in the last lecture, doesn't mean that you can't license ahead of time, even though those patents aren't, making commercial dollars, right? So probably the truth is that you probably could have 10 to 15 years of good licensing capability, although revenue probably doesn't start pouring in, of course, until it's actually in the marketplace, which would give you, at a max, probably 10 years of really good revenue and maybe only 5 because, it takes time to ramp if the patent really becomes valuable. So that's one thing, right? If the patent life is 20 years, what's the strategy for dealing with the fact that it takes so long? And in research, is before that timeline. Remember, the 10 to 15 years for commercial dollars is after the research. So if you're even further back and you're in research and discover something important early on, won't most of those patents be expired when actual commercialization happens? And the answer is probably yes if it's the most fundamental type of patents. So here we just reviewed the different kinds of things, but I'm different kinds of intellectual property, but I'm mostly talking about patents. And this is the some of the more practical aspects when you're trying to patent things, 10 years ahead of time, right? So we're thinking about fundamental, fundamental innovation here. So for sure, now scientists think they know exactly often, but the truth is, once they're successful innovators, they'll realize that it's very difficult to tell which patents will be the most promising. So it would seem that would encourage heavy patenting. The problem is that there's, of course, at the beginning, few resources. So there you have a catch-22. At the time when you could see something coming, you're very excited about it. You'd like to cover a lot of area, but the truth is that if you patent heavily, at this time, it's probably the time of few resources because you haven't moved down the innovation path. You're much further from, the end of the road where people can see they should invest more. Because the investing scenario is that the closer you get to the marketplace, the more resources get put in. And because of the risk, that makes sense, right? Because the further out in time you are, the less you invest. So you have to figure out what to do, and part of that is we've already mentioned this a little bit in the context that university people tend to file provisionals because they're going off and they're giving talks and stuff. But there's another reason the provisionals are interesting, is that they don't cost that much. So in terms of the few resource thing, what I can do is I can actually file multiple provisionals. Let's say I do provisional, 1, provisional 2, provisional 3, provisional 4, and I'm in a time period where after another year, I can drop, let's say, 2 of them, and I concentrate my resources on making non-provisional patents for 3 and 4. That's an example of a strategy of dealing with which patents, right? It's impossible not to lose some IP. You just can't annihilate competition completely. You just have to face that fact. And so really what you're after is building a better arsenal than anyone else. The other thing is that you better be careful if you're working for someone else. At a university, it's not a problem because you can license the patents into, that's the standard procedure. But if you're working for a company, this is actually a problem, right? Because if you're patenting things and it's in the field of your work, the company can always claim from your employment agreement that that's theirs. Now, if it's in a complete different area, let's suppose that you're working in a firm for electronics and you discover the cure for cancer, that's actually probably nothing to worry about. On the other hand, what are the chances that you're going to discover something really important, far outside your field of work, since we already mentioned that having an understanding of market application space and implementation is key to actually converging on the right innovation. So it's something to keep in mind. So this is actually one of the things that in Amberwave and other companies like that becomes really critical. There's sort of the conservative approach where a lot of people say, oh, I can't share because I have too much know-how and trade secrets and you guys are going to steal everything. So it's really just like investing. In the early days, if I draw, time, the risk is going to be the highest at the beginning and it's going to go down over time. Your resources first are minimal and they come up like this. So when you have minimal resources, you'd like to de-risk by making as many patents as possible, but you can't. So what you're going to have to do is compromise. You're going to have to kind of lay out what you can here. And, by the way, that risk is pretty high and you're seeing all sorts of companies that you're trying to work with. And so, yes, you sign NDAs, non-disclosure agreements, and you should do all that. But you're going to have to share something. So the key is to share things that, assume could be lost. Assume that you have some means to try to, through legal means, create problems for the other company. But more importantly, you should be picking your partners carefully. There's particular differences between companies, you'll notice, and some companies are friendly and some companies are mean. And generally, if you can work with especially in the early stages, if you can work with friendly companies that are win-win companies, which are generally the best, then you can, when you do this critical sharing, which you have to do at the beginning because you don't have the resources to protect everything, then that's the way to go. So relationships are one of the key things, mostly because this kind of view that you're going to be able to patent everything and protect yourself completely and that new ideas won't show up and all this sort of thing is kind of not really the way it ever works. So the other thing is that patent law could be very expensive, but with that specific partner, you can still do contract law. And remember I mentioned that contract law is business to business, so it's good. It's not as strong as patent, where the federal government gives you a monopoly and the federal government is standing behind you. But actually, contract law is still good, and you still get arbitration, and you can still, companies still don't want to break contracts and do bad things to their partners, especially companies that do win-win. So again, you're going to have to, in the early stages, share. The other thing is that, in the early stages, the advantage is that even though you think your stuff is so important, not a lot of other people are really thinking about it in great detail. They just really don't have the time. And so if they hear things from you, they can't really go out and execute it like you could, knowing those pieces of information, because they don't know as much as you. So in general, there's a bunch of compensating mechanisms that, as long as you're aware, you can actually proceed until you get more resources and you can afford to patent more. So, if you're doing a fundamental technology, the really cool thing about it is that big, tough problems make great patents. So the solutions to those early research problems are actually great patents. So one way to think about this is that you're depressed when you see problems along the way that you encounter in trying to commercialize something or create an innovation. But actually, that makes the best intellectual property when you solve, when the problem's solved. So that problem is going to be the problem that everyone has to pass through. And therefore, yes, you're depressed when you see it, but just think of the day that you solve it and that you get the intellectual property affiliated with the solution. And those solutions, the further out you are, the more likely you can get broad claims because there's less out there. And it's protection from the fact that the market application, technology, and the implementation will surely migrate because they, as we know, change with time and select and do all sorts of things. And so, you're trying to build something that will protect us even though we know that the iterative innovation process is happening. Now, one way to do that is to keep refining the patent direction. So just like little risks here converge, right, you would follow the patent strategy. That's why I said if you do all those provisionals at the beginning, P1, P2, whatever, that's one strategy for trying to migrate at the beginning. And then a strategy for migrating later is called the CIP. If you have broad basic things that you keep open, you can create a continuation in part, which means that as you develop nuances in here and you take the research in a new direction because the innovation process is converging somewhere else, you can do add-ons. These are add-ons. You can add on a CIP, add on a CIP. And that way you kind of slowly fill in areas. Remember, we're talking about the field and about claims. So you might start here, but what CIPs do and all these strategies we're talking about is that even though the rich space of the innovation looks like it might be over here over time, what these other strategies do is allow you to kind of converge and try to cover those additional areas, which you can't see initially until you go through the iterative innovation process. Oh, I just wanted to point out that the future filings become probably more valuable. And the way to see that is, so let's suppose that we have this 20-year lifetime of a patent, or let's say a 10 to 15 year for fundamental innovation to reach the marketplace. So dollars first start appearing here. Obviously, if you go back from here 5 years, here you have a pretty good idea what this thing's going to look like. Like maybe it hasn't converged all the way, but in our model, the things are getting pretty close and pretty narrowed. So by definition here, you can make more specific IP, where back here, you're trying to be kind of broad. And so you need a continuous strategy so that as you get closer and closer to particular market applications, you then patent very specifically. And of course, these end up being more valuable, assuming that you can do them before anybody else, because others are watching you come in here, of course, is that they are probably going to be pretty targeted because they're only 5 years away. And you have, even after this moment, you got 15 years left, right? So the way to think about it is the early patents are great. They kind of get you into the first part of where the commercial revenue is. But the patents you file closer to the real invention, if you can do it before anybody else, where the real value is, they will give you a boost, and that's where the real value is. So this kind of shows you that why university patents really aren't that valuable unless they're part of an innovation process, because the chance of these things by themselves being valuable is pretty small. But as part of this process where you're monitoring the iterative innovation and you're skillfully changing this as you go along, then this could have some value in the early stage, but more importantly, it's supporting the other patents that reach out further in time. So this is very important, actually. Once you have the patents, you probably want to think in this order about how you want to use them. Remember I said that you usually have to penetrate the marketplace first before you would even be forced to become a licensing company. And you can see that here in this list, because you would always look to partnering first. That is that, assuming that you're not a monopoly and have all your own infrastructure or whatever, and usually if you're carrying a new idea to market, that's not the case. So you have, to partner with people, Amber had to partner with materials manufacturers, fabs, integrated device manufacturers. And you're partnering because everybody has, a win-win goal. And, yes, the value is going to be partitioned eventually. But, in principle, you could carry that together forward and all share in that. And that's the best situation, because the iterative innovation process continues through partnering. And it allows you to develop more important intellectual property down the road, as well as your partners. But in a way, you're forced into licensing only if things change there, and your only play is licensing. It could be because you're very successful, right? Like strained silicon, it goes everywhere, and it just goes everywhere so fast. Your only thing is to collect on the licensing. That's kind of a, Qualcomm did the same thing with phones. Once it took off, they realized they weren't really the best phone manufacturers or whatever, but there's lots of people jumping in, and so they could just license the CDMA technology. And then, of course, the only time you're forced into litigation is if someone is using it and decides not to license it because they don't think they need to or whatever. So that is the real correct ordering, and you should think of it that way. Of course, licensing is a good toolbox. You can cross-license. In our case, going up against the big guys, you definitely needed to have something, which is, of course, the innovation, but also the patents around it. Litigation is always the last resort, but unfortunately, sometimes it needs to be done. Shows you the first version of Intel strained silicon. They did a couple things. One is that, remember I explained to you that they were an IDM, so they were integrated device manufacturers. So they did everything in that whole vertical supply chain, from process to devices and processing devices into an integrated circuit, design, all the way up to selling to the customer, right? The only thing that they didn't do, they still buy silicon wafers from the outside. That's the only thing that other people have, gone into the disaggregated. So, our plan was, of course, we worked on 3 levels: the silicon, the process, device level with other manufacturers, because they were disaggregated, meaning that they were a foundry business and the fabless design company, etc. So, in this case, Intel, being the largest IDM with the most market power, has a lot of resources. And what they did was they developed their own internal process for this. And their process has silicon germanium over here and silicon germanium over here. And it actually compresses it. So this is much more like, in our case, the patents that we have around this, compressing a column 4 channel. We did with compressed germanium. It turns out germanium and silicon have the same kind of valence bands, and if you compress silicon far enough, it looks like germanium anyway, because curvature gets high enough. So this is where all the cutesiness comes in about how do you try to get around patents? How do you try to write patents that cover the idea? Because there's 1,000 different ways that this thing can happen. And like I told you, just here silicon germanium is all around, but remember the original thing that we had was that silicon germanium was underneath, right? But remember that we actually went all the way up to strained silicon devices and simple circuits because we were the first ones doing all this. And so we had patents like the following. This is a good demonstration of a vertical research and development and vertical patenting. When I say vertical, what I mean is, again, Amberwave was an intellectually vertical company. Had materials, devices, processing, and device patents, and even some simple circuit ones. But we could only reach up so far because our resources were limited, and we did these things by partnering with outside infrastructure, especially the materials, the processing. We partnered with outside firms. So we're vertical in intellectual thinking and research and intellectual property, but we were using external infrastructure to do this. So that allowed us to make patents through here. So vertical patenting means that if you're doing the work, you don't not patent it. You should patent all this stuff. So here's an example of a wonderful patent that we had, which is method of fabricating CMOS inverter and integrated circuits utilizing strained surface channel MOSFETs. So we realized that the way that a inverter, which is the basic element of any digital circuit, would change because the hole channel through compression and the electron channel through tension would change the ratio of the electron and hole mobilities and drive currents, and so it would change the design. So that's what this patent's about. And clearly, you can see this doesn't really depend on the details of what's happening below here, because just the fact that any form of strained silicon does this, right? So that's an example of how, even though there's 1,000 ways always to do stuff, if you're early and you actually have many methods through the entire thing, and you can write broad patents because you're the first inventors, then you can cover a lot of area.